Hey guys, it's your boy Automotive, and today we're going to be doing some basic diagnostic work on this basic circuit. Don't worry guys, principle remains the same. So don't stress yourself saying that this is just basic circuit, so is this going to work? It can work, trust me. If you understand the principles of checking a circuit, then you'll be fine. Here we have the diagram that I drew of this circuit. The battery current goes down to my switch, then it goes down to the fuse, even though the fuse should be first, but it doesn't matter. Through the fuse to the horn to ground. Simple circuit. So when this is closed, horn making a lot of noise, it's grounded, everything's good. This again is a basic test light, and the way this works, it's just a bulb in series. So power comes here, goes through the bulb to ground, or you can put this on negative and put positive, and put this on positive. Positive travels here through the bulb to ground. So from this circuit is completed, the bulb will light up. Here we connected the negative. So we're going to be testing the power side of the circuit first. The power side of the circuit, we're going to test that first. So always test your equipment first. That goes to the multimeter, the LED test light, your regular test light. Always go first. Always ensure this light. So that's the first thing you do. Ensure you have a good ground on your test light. Test it, then you're going okay. So let's go down the circuit. Why doesn't the horn blow, guys? I'm wondering. So following the diagram here, goes to our switch. So we're gonna check here. Comes down to our switch. Here we are. So that's the one coming in from the battery. But I don't have nothing on the next side. I wonder why. Whoa. I just had a brainstorm. Whoa, the switch isn't on. This is a horn, guys. It's gonna make a lot of noise, so I'm gonna just place it on the next side like this and switch it on. See, guys? So when you switch on, the power sends on and goes down. If you wanted to test the ground side, you'd have to change your meter. Not your meter, guys, sorry. Your test light lead, put it on the positive side. So now, when any grounds you touch with your test light, lights up. So let's test the ground side. Here we have a little splice. Oh, whoa. Sorry about that. I didn't have any clips for this. So we're gonna touch here on the wire. Here we have ground going on here. We got ground. Touch here, ground. Still have ground, but I wonder why ground is on the power side. Remember, when the switch is off, when the switch is open, ground will be able to, the whole of this side will be ground. That's because no power is being fed on this circuit. Once this switch is open, that's how the circuit is designed. So here we have power, we got ground, sorry. Go right up. We got ground here. Understand? Next side is not going to be grounds because this is power. Right here. That's power. So we'll put the test light there, no light. We're going to get light here because the whole side of here is ground. So I'm going to rig a problem in this circuit. Here we got a problem. The horn doesn't blow. I wonder what's going on. Let's diagnose this. we're gonna check if this switch is getting power. So let's begin that. So we're gonna ground our connector there. Test, ensure the test light is properly grounded. Move it on. We're getting power at our switch, guys. So a next thing that you would do to be sure a customer comes in with this problem, why not just go straight to the source? It's simple and it's more realistic. So you would go outside, you open the car, and then you have these the connectors here at the horn. Remember, this could be a headlight or anything else. We're supposed to have power on this, but ensure the switch is on. Okay, so the switch is on. Horn is not blowing. We touch here, see if we have power. What do you know? No power. So looking at the diagram here, we went here and there's no power. So we need to trace between here and here because we have power here. So let's trace between here and here. So we have power here. We have power on the next side. Going down. Oh, I think I see the problem already. Power on one side of the fuse connector. No power here. So that's the problem. There's no fuse. You can substitute this for like a blown fuse or something like that. So here's our fuse. See it? So it was just a fuse, guys. Simple as that. So now I'm going to show you how to use the LED test light. Alright, here's our LED test light. This is the one I made. Don't worry, I'll be showing you guys how to make this soon. So we're going to use this and do some work. So the way how this works is you got two sides. You hook this up, you don't have to switch again. This test light shows you positive and negative. And this is more computer friendly because the newer cars today use computers to control their different circuits and systems. They are very low current systems. So the other test light is not really recommended to be used on those vehicles. This has resistors and stuff inside. So that's why this would be more recommended to be used on those type of vehicles. So let me connect this up here. Right, so here we got it connected. As I said before, ensure it works. Here we got red on the positive side. See, we got ground. So it's the same procedure, guys. You come here, you got red. Come here, you got ground. So red and ground. This is how you test a fuse. Here you got the fuse. I'm gonna test the fuse. You come to one side and you probe it. And you come to the next side and probe it. Ensure you get the same light on the both sides. If you go on it and one shows red and the next one shows green, that fuse is blown. There's an opening in that fuse. So that's how this is used. This is very, very simple. It's used in the same way as the next test light. It's just that it shows you ground and positive without you have to be changing the clips over and over between positive and negative on the battery. So I don't think I have to go in too much depth of this. So I'm going to show you the multimeter now. Here we got the big boy, the multimeter. Multimeter, as I said before, has resistance, direct current, alternating current, frequency, voltage. It's got all what you need in one. This one shows temperature, so that's all you need. So we're gonna do some regular checks. First of all, the first thing you need to make sure the black lead always goes in the COM port. COM. Yeah. Smutty minded people. Okay, and the red one, if we're checking for voltage. So here we got the voltage sign. So I will make sure this is in the right one because we have the current ones here. This is for high current, this is for low current, milliamps. We're checking voltage, so we put this in the voltage. The black always stays here. Okay? Moving on. So the black one is our ground. We place that here in our ground. Turn on the meter, guys. Don't be like me and forget to turn on the meter. So we put it on 20 volts. Setting the meter is important. Ensure we know this is a 12 volt battery, so we're going to put this at 20 volts. Because this meter has resistance inside, you got to set this at the right amount so it knows what resistance to put on the circuit. So this meter doesn't goes ply or goes like the iron. Turn it on. Here we are. So I'm going to just test my meter. There we got 11.78. Yeah, we got roughly enough to get the horn blowing. So it's the same procedure. You just go around, but this just shows you the exact amount of voltage. So now we go to our switch here. We go to one side of our switch, and we look at the meter again. It's 11. Then we go to the next side now. That's here. We're going down this side now. We'll go here and look at the meter. Nothing. Why is it nothing? Because ground travels up. Try to remember this. Ground travels right up. Don't get confused. Okay? The meter won't lie. I got a funny joke on something like that, but I'll tell you that in another video. Alright, so it's the same. Alright, I'm gonna turn on the switch. Gonna be a little annoying, but I'm gonna turn on the switch and look. I'm gonna go on the fuse side of the part of the switch. See, we got 0 volts. I'm gonna turn it on now. See how much we got? Let me do it again. Hold on. Sorry about it. Inside there. Alright, I'm on it now. I'm gonna turn it on. This is the fuse side of it. You saw the reading? One more time. That's it, guys. So it shows. So let's say we wanted to, sorry, let's just jump off again. Remember, that's a slapdash piece of shit. Alright. So let's say we wanted to test for like a voltage drop. You take your meter, wherever that is, and you go across. Let's say you're testing across the load. That makes sense because this is not being turned on. Okay, I'm not gonna make any more noise in the place. So that's why you do a voltage drop. You have to go across the circuit. Remember, voltage is measured in parallel. So you measure in parallel. Let's do this in series. In series, you check current. Since we don't know how much is the current range, we're going to put it at the highest amount that you have on the meter. My own is 10. So I'm going to put it at 10. And remember to change this over. always measure this in series. So here we're gonna pull here. Hold on, I'm kind of weak. I'm gonna pull it here. So one goes to one side of my meter. And the other end goes to the other end of my meter. Remember, in series, current is constant. So whatever reading we get here, it doesn't matter where we do it, we're gonna get a constant reading. So I'm gonna turn on the horn, look at what I get. You can press hold to stop, pause it so you can see the amount. Alright, I'm gonna do it now. So here we have 1.62 amps of current. So that's how you test it. So you notice the current goes through my meter and goes to ground. So that's how you check for current. Now to check for ohms, you have to make sure the device is disconnected. So you disconnect the device, you put this back in the ohms region, and then I can check for continuity. Continuity is like it's measuring to ensure that between the component there is no breaks or any what you say now, corrosion, high resistance. So we're supposed to get a beep when we place our meter like this. Oh, take off the hold and then show you have it on that. So there you can see across the horn we got 4 ohms. So that's how you test for continuity. Say you got a wire, you want to test across it, one on one side, this on the next. Got it? So that's alright. This is very important, guys. Never do a test with the circuit unplugged. If you do that, you're going to get wrong readings. Ensure that the circuit is energized. Remember, voltage. The only thing that you check without the circuit being completed with a positive on the ground is resistance. So ensure the circuit is complete. Do not plug off the component that you're testing. Here is a perfect example of what I'm talking about. Sorry about that. Alright, I'm going to show you a perfect example of what I'm talking about. Let's say we connect this positive to our battery. So we're connected to positive. Ensure the meter is okay. And we're going to use our negative. Do not do this, guys. The on is already on. Never do this. Look at this. This is battery voltage. You're gonna say the horn is bad because it's getting voltage here, right? Hold on. It's getting voltage here, so you're gonna say the horn is bad. You're wrong, because watch this. When I plug this in, look at the difference I get when I measure it. I'm on it, guys. That's the amount of voltage I get when I do this plugged in. If you didn't do this plugged in, you would have not seen that this horn is not getting enough voltage. Voltage is divided in a series circuit. This tells us that there is a fault in this circuit going back, because you're supposed to get your 12 volts at the horn, or 11 volts right here. So there you can see you're only getting 8 it looks like 80 millivolts. That's what you get, 80 millivolts. And that's not enough. That's not enough to blow this horn. So let's check back the circuit. And guess what? We were right. I wired in a resistor in this circuit. Here we got 60 millivolts. And on the next side, look at that. There's our voltage that we've been losing. This is a series circuit, so voltage is divided over the larger one. Voltage lost here, voltage lost there. So this was what was dropping our voltage. Here we touch it, look at it. Got something is wrong here. We're dropping the voltage. So a little trick, get a jumper wire and jump it and see what happens. So put one there, put the next one there. So you see, jumping it does it. So that shows you that this needs to come out of the circuit for the horn to work again. Hope you like that video.